All right, so there was a second part I just went to close the video too soon. Part 2 wants to determine if the relation is a function. If it is not, we're going to identify two ordered pairs as proof. Okay, so function, to determine if this is a function, we have to use the vertical line test. Okay, so let me give you a little background on the functions that we saw. So here is the little story I like to use for a function. Let's just say that there's a dad, he has a daughter. The biggest and the most primary concern that dad have with their daughters as they get older is the dating of boys, because we know how young men can be. And of course, all dads are young men, so they know how we were. And let's say that dad says that daughter can go out and date, but she just must follow one rule, that she must only date one boy at a time. So we don't want her, trying to date more than one guy. And so we're going to just say, and this is just a dating game just for fun, okay? It doesn't mean anything. This is just an example to help explain functions. Okay, so let's just say, let's use it like a dating game. So let's say that X is the night that we go out. And then Y is the guy. Okay. And these, again, are arbitrary. They don't mean anything. So let's say on first date, we go out with guy number 5. Okay. And then, okay, we go second date with guy number 3. And let's say third date, and these aren't like have to be the same day in a row, but again, just for arbitrary, we go out with guy number 2, and let's say that of these 3, they like 5 the best. So let's say on fourth date we go try 5 again, and then still not really. So we haven't broken any rules. So one at a time. So any given night, there's only one date happening. Okay. Even though you go out with the same person again, that's okay. So that means the Y value can repeat right now. But let's say on the 5th night we try to get sneaky and we have 2 dates. We go out with maybe guy number 1 and guy number 10. Okay, so right here's a problem. This is where we're not functioning. This is breaking the rule. We cannot have 2 dates on the same, so we can only one at a time. So this is 2 at the same time. So this is where we break the rule of being a function. I'm just going to say not function. Okay, the rule says each X is paired with exactly one Y. Okay, here we have the same X paired with 2 different Y values. This can also be represented with a vending machine example. Okay, so let's say we have a vending machine and we have a button that gives you Coke. We have a button that gives you Sprite, one that gives you Dr. Pepper, one that gives you root beer. Now this has happened a long time ago, but maybe not so much recently. So let's say when you press Coke, you expect a Coke to come out of the machine. When you press Sprite, you expect a Sprite to come out. Same thing for Dr. Pepper. You press that button, you expect to get a Dr. Pepper. And if you press root beer, you expect to get a root beer. But what if when you push Coke, sometimes you get a Coke and then sometimes you get a Sprite? So in a mapping, sometimes they will use these. This is a problem here because you have 2 lines. This is the domain, first set, and this is the range. Okay, so if you have 2 arrows coming from the same domain value, meaning you're getting 2 different things with one button, that is not functioning, so that would not work. But you could have, and you've seen vending machines like this, there may be a Coke button at the top, and then there may be another Coke button at the bottom. As long as both of those give you Coke, it's fine, and it doesn't matter what's in the middle. But when you have this scenario where you're getting two different outputs with the same input, there's something wrong. So two visual examples of functions. It also agrees with the vertical line test. If I was to list these ordered pairs, just for this one, for example, I would have 1, 5. I would have the ordered pair 2, 3. I would have the ordered pair 3, 2, 4, 5, and then we would have the ordered pair 5, 1, and the ordered pair 5, 10. Okay, so when the x value repeats, because we got 1, 2, 3, 4, 5, and 5, when that repeats, not a function. When the y value repeats, it's okay. The second coordinate can repeat in a function. If I did this on a graph, here's y, it fails. This is why the vertical line test, and they're all the same thing. Let's just say I go over 1, up 1, 1, 2, 3, 4, 5. That's my point. And then here I'm going to go over 2, up 1, 2, 3. Over 3, up 1, 2. Over 4, up 1, 2, 3, 4, 5. And then over 5, up 1. And then let's say 10 is way, way up here. If I was to draw a vertical line through all of these points, it would hit twice right here. This would only hit once, 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 once. So vertical line test is agreeing with the same thing. The x value is repeating, giving you two different outputs, 5, 10, and 5, 1. So that's why vertical line test, the repeating of the x coordinate is failing to be a function. All right, so in this example, if I did any vertical line, most of them are going to hit twice. So let me pick some whole points. Let's just say this one and this one. This would be x value is 1, ordered pair is 1, and then 1 and negative 3. So this is not a function because it fails. And then ordered pairs, you can really pick any, but you want to try to pick some that have whole values. And so I'm going to use 1, 1, and then 1, negative 3. So again, that just comes from this point, giving me some whole numbers there.